need to integrate external tools into your DSPy agents through a clean HTTP interface. You'll see how to connect to an MCP server, fetch its available tools, and automatically convert them into DSPy-compatible tools. Then we'll build a simple ReAct agent that uses these tools to complete a task, like checking the weather, with just a few lines of Async code.
Import Asyncio. Import DSPy. From MCP, import client session. From MCP, client, streamable HTTP, import streamable client. Async def main. Hash connect to HTTP MCP server. Async with streamable client. http://localhost 8000/MCP as read write. Async with client session. Read write as session. Hash initialize the session. Await session initialize. Hash list and convert tools. Response equals await session list tools. DSPy tools equals DSPy tool from MCP tool session tool. For tool and response tools. Hash create and use ReAct agent. Class task signature DSPy signature. Task SDR equals DSPy input field. Result SDR equals DSPy output field. ReAct agent equals DSPy ReAct. Signature equals task signature. Tools equals DSPy tools. Max iters equals 5. Result equals await ReAct agent. A call task equals check the weather in Tokyo. Print result. Asyncio run main.
This demonstrates protocol-agnostic tool integration, where a DSPy agent dynamically incorporates external tools through a standardized conversion interface. The code connects to an MCP server, retrieves its available tools, and converts them into DSPy-compatible tools using a one-line transformation. The distinctive aspect is how it treats third-party tools as first-class citizens within DSPy's ecosystem without manual adaptation. The implementation follows a straightforward flow. Establish a transport connection to the MCP server, list its tools, then convert each tool into DSPy's native format while preserving its original functionality. The converted tools maintain their original names, parameters, and async execution capabilities, but now operate through DSPy's uniform interface. This allows the ReAct agent to use them transparently alongside any native DSPy tools, with no additional protocol handling in the application logic. This pattern matters because it eliminates the need for custom tool adapters when combining different AI frameworks. The example shows how to leverage an external weather checking tool, or any MCP-exposed tool, directly within a DSPy agent, keeping the agent's implementation clean and framework consistent. The approach is particularly valuable when you need to compose tools from multiple sources while maintaining a single, unified agent interface. Let's break it down.
Import Asyncio. Import DSPy.
Imports Asyncio for running the async event loop and DSPy for creating the ReAct agent and tool signatures. These are the core dependencies for the script's AI agent execution.
Async def main. Hash connect to HTTP MCP server. Async with streamable client. http://localhost 8000/MCP as read write. Async with client session. Read write as session.
Declares the async main function and establishes a connection to the MCP server using a context manager. The async with pattern ensures proper resource cleanup while providing the read-write streams needed for the client session.
Hash initialize the session. Await session initialize.
Establishes the baseline connection state for the MCP session. This call must complete before any tool operations can proceed.
Hash list and convert tools. Response equals await session list tools.
Queries the MCP server for its available tools using list tools, returning a response containing the raw tool metadata. This provides the foundation for converting MCP tools into DSPy-compatible tools in the next step.
DSPy tools equals DSPy tool from MCP tool session tool.
Transforms each raw MCP tool into DSPy's standardized tool format using the session context. This adaptation step bridges the server's native tool definitions with DSPy's ReAct agent requirements.
Class task signature DSPy signature. Task SDR equals DSPy input field. Result SDR equals DSPy output field.
This creates a task signature class that inherits from DSPy signature, explicitly defining the agent's input and output schema. The task field marks the string input using DSPy input field, while result declares the expected string output with DSPy output field, establishing a strict contract for the ReAct agent's execution flow.
ReAct agent equals DSPy ReAct. Signature equals task signature.
Instantiates a ReAct agent using our task signature class. This signature defines the task's input-output schema, ensuring the agent processes requests with the expected task, input, and result output fields.
Result equals await ReAct agent. A call, task equals check the weather in Tokyo. Print result.
This invokes the ReAct agent with the task string, triggering its multi-step reasoning process. The print result simply outputs the agent's final answer after it completes all iterations and tool calls.
Async run main.
Executes the Async program by starting Python's event loop with main as the entry point. This is the standard pattern for running top-level Async code, replacing manual loop creation and cleanup. DSPy Async client pattern. This code establishes an Async connection to an MCP server using streamable client, wraps it in a client session, and executes a single ReAct workflow. The task signature defines the agent's input-output structure, while Asyncio, run main, handles the event loop execution. The initialize call is a required but empty protocol step. No custom setup occurs. All tool interactions flow through the converted DSPy tools list, with explicit await syntax for each async operation.
The session that initializes nothing connects everything.